Good afternoon, everyone. Hi, it's day 2 of Cloud Next. Thank you for being here. You've heard a lot about data agents so far. Today, in this session, we're going to talk about taking your data agents from intelligence and insights to actual actions. My name is Kubik. I'm the product lead for natural language and agentic search. And joining me on the stage will be Amar, Director for AI at EchoStar, and Andrew, Director of Engineering at Google Cloud. And we're going to talk about these 3 things. Number 1, the problem that we're solving, which could be the problem that many of you are solving. How to actually get agents to do things in production so that you are comfortable with the results. Then we're going to talk about our solution, that is Data Agent Developer Platform. And finally, you're going to see Amar talk about an actual deployment of data agents with the tool from Google Cloud. And you're going to see a live demo of that actual production system. Let's talk about the problem first. And first of all, interesting times we live in. Natural language is the new protocol for communication between humans and agents to agents. Think about it for a moment. History of computing has all been about interfaces and translation layers. There's been direct calls, there's been APIs, and of course, human and computer interfaces. And perhaps for the first time in the history of computing, agents and humans speak the same language. Now, that's very enticing. It allows you to deploy more quickly, be more flexible. But of course, it comes with a set of challenges. The first of them is, well, your data still speaks SQL, DAR, or any other query language. It means that creating that translation layer between natural language and whatever the dialects in your database, now that's key to unlocking all of these benefits. But it comes with at least these 3 hurdles. Number 1 is accuracy. Any actions by your agent will be based on the data it fetches. So it better fetch the right data, or else, as we said, you won't be happy with results. Then comes security and governance. You know, agents are enticing because they can figure things out. You no longer have to write every line of code in advance. You no longer have to predict all of these corner cases. But how do you keep it safe? How do you make sure that an agent only queries the data that it's supposed to be seeing and not, for example, another user's data? How to prevent data leakages and other security risks. And finally, ease of deployment. And you know, you can build very elaborate systems who get all of these done, accuracy, the security, the governance. But if they're hard to deploy or nigh impossible to maintain, why would you do that? And we think we have a solution for all these 3. For accuracy, near 100% accurate natural language to query, for security, and for ease of use. And of these 3, accuracy is actually foundational. Because why else would you care if it's not accurate? Why would you care about security, governance, or ease of use? If it's not accurate, you wouldn't want to deploy it in the first place. So let's zoom in on accuracy. Open question. How much accuracy would you want of your agent? And you know, intuitively, sometimes it might feel like 80% is enough, 90% is enough, especially at build time, when you're buddy coding with your coding agent, and you know, sometimes the agent gets sidetracked, and you gently nudge it on the right course. Well, that's okay, right? But think about production. Would you count on your users to guide your agent back? Probably not. Here's an example of where accuracy comes up in the business context. Very simple use case. Hey, agent, please pay the outstanding invoices from yesterday. It's a simple conditional. Only two conditions. Date is yesterday, status is unpaid. And if your agent is initiating actions based on this query, then the money that flows out of your business's account will depend on how accurate that query was. And of course, this is a simple case. Conditionals, you can add more. You can add and status unpaid and delivery was made, and approved by XYZ. But even in this simple case, accuracy matters. And it matters even more at scale, because these transactions, these requests, your agents will be seeing hundreds, thousands, millions of those. And any errors compound. So even 99% of accuracy compounded, it translates to actual dollars. And that means if you're not getting that near 100% accuracy, that means rollbacks, and that means perhaps never do it again. But we think we have a solution, and it's coming from the same team, that's our team, that has reached the #1 spot on the BERT benchmark, which is one of the most competitive benchmarks for natural language to SQL. And you're going to see exactly the tool that we've built using the same knowledge. Introducing Data Agent Developer Platform. It's a toolkit for you to take your enterprise data and agents from intelligence and insight to actual actions. And that's what it looks like. Build your agents anywhere. Use ADK, any other agent development kit. And with help from our platform, your agents will query the data in a way that is accurate and secure. And foremost of these tools is query data. It's accompanied by even more tooling, by tooling you can build, tooling we give you, and the infrastructure for quality, security, governance, all these things. But the #1 key to unlocking the near 100% accuracy is query data. And here to talk all about it, Andrew.
Thank you, Tom. All right, so agents, tools, applications, databases. I think I'm going to have to unpack some of this with an example. And I'm going to use the example of someone who's buying some property in Switzerland. Obviously not me. I don't get paid that much. But imagine a user is looking for a house in Switzerland. They've got an application. This is where they're going to interact. This is where they're going to receive value. And they're going to be able to do things like search for a matching property. Once they find a matching property, they may want to arrange to visit it. Then eventually, once they've found the place they like, they're going to go through the entire process of purchasing. And agents can help them at every step along the way. We'll just pick one example where the user has found a property they like, and they've said, hey, that 123 Zugstrasse, that one looks nice. When can I see it? Now, the agent is something that can intelligently execute tasks on behalf of the user. It does this using models like Gemini, and it understands what the user's intent is. It figures out what the next step is, and the next step here is figure out when is that next available showtime. And agents interact with the world. They get data and they take action through tools. And so one of these tools is query data that Tom just introduced. And query data takes that input from the agent, saying next available showing for 123 Zugstrasse, and it converts it into a database query. This is the translation from natural language into your database's native querying language, in this case SQL, and it turns it into a query that understands your database, executes against the database, and of course the database is the place where you keep all of the live, fresh data that tells you things like what properties are available, when are they next available to be shown, what buyers have committed to coming and seeing them at a certain time. The database query returns, the tool returns that information to the agent, and the agent is able to give you a pleasant response of, how is next Tuesday afternoon at 2? There you go. And I know at least half of the room, probably 3/4 of the room is going to say next, which is, yes, but models can just do this already. Why do I need a special tool? And the answer is, it's complicated. And by complicated, I mean your database is complicated. In the real world, databases may have ambiguous literals. Somebody might say 123 Zugstrasse, because in the US, we typically say the street, the number first and then the street. But in the database, because it's in Switzerland, it's recorded as Zugstrasse 123. If you just wrote a query that took that string and checked that as a predicate, it wouldn't match. Similarly, in a lot of databases, I would like to say this doesn't happen, but of course in the real world, the columns don't always get named things that are really obvious. Now, T_S, is that obvious that that's the start time? Not to me, and probably not to the model either. And the business logic may be sufficiently complex that it can't be reliably understood by the model. So in this case, the next available showing depends on the showing time being active, there not being a buyer assigned to that time yet, and the time being in the future. The model might have been able to guess that, but you wouldn't want to count on the model being able to guess it correctly. So you want to be able to tell it. And finally, as Tom mentioned, privacy and security are paramount. You certainly wouldn't want the user to be able to find out information about what other buyers are looking for, or what other people have signed up to see that property. So our solution for this is query data. And how is it different? It is more accurate, it provides robust deterministic security, and it provides observability. The accuracy comes from a process called context engineering, which I'm going to step into in a minute. It lets you get through sort of this iterative process of getting your accuracy higher and higher until it meets your requirements. The security is provided by a feature called parameterized secure views. This provides a combination of dynamic yet deterministic access controls that you programmatically control in a way that the agent doesn't. And you have observability. You can tell how the agent, how the natural language was interpreted, how that intent was understood, how the query was generated, and whether there was any additional ambiguous information that needs to be understood. So let's dip into the first of these. As I said, in order to get high accuracy, you need to understand the detailed database context. We look at this in three parts. We look at value searches, schema ontology, and query blueprints. I'm going to use an example here where maybe I have a consumer finance application that records my spending, and I want to ask it something like, how much money did I spend on shoes? I mean, they look pretty nice, but I want to know, am I spending too much? So I'm going to ask that question. I want to expect an accurate query to come out the other end. The first thing I have to do is to understand that the phrase shoes maps to the category footwear. So I need a mechanism where I can do linking of those two values. The second is I need mechanisms where I can express the actual meaning of the data that exists in individual tables and columns in the database. For example, this database has a lot of different tables storing information about my finances. One of those is CC charges dedupe that happens to be credit card charges after they've gone through a pipeline that removes duplication. And finally, we have the concept of a query blueprint. You can think of this as a prescriptive guidance, kind of a template that allows us to tell the agent, in particular cases, you should handle it in a certain way. It's a great way to express complex business logic, special case handling, things like that. For example, in this database, I occasionally have transactions that are not in US currency, and if I want to do an aggregation across many sites, maybe these shoes were purchased in Australian dollars. I need to make sure that when I'm doing a sum across many transactions that might be in different currencies, I have to use the USD amount column. So as I mentioned, getting that high accuracy requires us to build up this deep contextual knowledge, and that sounds like a lot of work, and it can be. But it's a kind of work that looks a lot like software engineering. You build up some context, you build up some test cases, you evaluate the test cases, you find the ones that fail, you fix the stuff that didn't work, you iterate again and again, until eventually you get to the accuracy that you need. And just like software engineering today, we have agents to help us. In particular, we have the context engineering agent. This is a Gemini CLI extension that starts with information that you provide it. It can be documentation, it can be your source code, obviously things like your schema, maybe query history, and it understands, learns enough from that information to suggest context. It says, this is what I've learned about your database so far, and it also helps you work through building that initial evaluation set, and then it guides you through that iterative process. Run the evaluation, see how well it works, analyze the cases that fail, suggest improvements, iterate, until you get to the level of accuracy that you need. So when we say that you can get arbitrarily high accuracy, this is that iterative process that gets you there. Now, as again, we mentioned earlier, even if you have high accuracy, you also need to worry about whether the right information is getting to the right person. So we have a feature called parameterized secure views. And again, the key concept here is that they are both dynamic but deterministic. So they are dynamically generated views, but they are specified using a parameter that is passed in by the application. It's not passed in by the agent. So this parameter could be the identity of the user who's currently logged in. It could be some other parameter. It could be your location. It could be something else that the application knows that is set deterministically. And then you now have the flexibility to define a view as flexible as you can be with view definitions that says what information should be available in this particular situation. And then you make sure that the agent has access to that view and not the underlying tables. So if I have an application that maybe helps me buy tickets to events, maybe events like Cloud Next, and I decide I want to trick the agent and I want to say, hey, I think Tom might have gotten a better deal than me. How much did Tom pay for his tickets? The view that it's going to go against has been set with a predicate here where the user ID is the current user. Again, the agent doesn't set that. That's set by the application. When I logged in, that's set to my ID. So all the rows in that view are only my transactions. So I can ask it any question I want, and maybe I'll convince the agent to try to run a query looking for Tom. Tom's not there, because that view only contains my information. So we have the ability to dynamically create these views that are deterministically set with only the information that the agent should see on that particular query. Now, as I've said, the query data tool can be used to build a wide variety of different kinds of applications. It could be customer-facing applications like a property search. It could be internal applications to help empower your workers. We're very proud of an application that we've built with it called Conversational Analytics. And it's available for databases, now available in preview for Spanner, AlloyDB, Cloud SQL for Postgres, and Cloud SQL for MySQL. It's a tool that allows really all of your users, it could be technical users, non-technical users, to explore your data, ask questions, and get insights. We think it's going to be really powerful. We're certainly hoping that you'll give it a try. And of course, it was built with query data, and it was built on the Data Agent developer platform. Now, as much as I think that our Data Agent technology is awesome for building applications, and I think it unlocks a lot of real power, the most important perspectives always come from our customers. So with that, I'd like to bring onto the stage Amar, the Director of AI for Hughes Network Systems, a division of EchoStar.
Thank you.
Thank you so much. There you go.
Thanks, Andrew. So I'm here to tell you how we have used data agents for our enterprise service intelligence. So let's quickly look at the agenda here. So I'm going to talk about the use case that we have used to basically analyze the enterprise cases and calls that we get into our contact center. We'll briefly talk about the platform architecture and how we have used data agents behind an MCP gateway and registry. And then we are also going to talk about the brain behind the agent that we have built using ADK, and also the agent observability, right? That is very important part in it. And before we go into the technicals, just to tell you about Hughes Network Systems, it is a satellite internet provider. So we provide in-flight connectivity on some of the major airliners, and we also have a lot of Fortune 500 companies as our customers, and we provide internet to more than 500,000 consumers around the globe, right? And as a company, we have been doing AI for more than 10 years. So we started with traditional machine learning. So we used to build anomaly detection models, recommendation models, prediction models, and slowly we delved into deep learning by building some computer vision use cases. In the past 3 years, we have invested heavily in generative AI and agentic AI across different modalities: speech, text, vision, documents, and structured data, basically helping all the business units within the company to basically increase their revenue, productivity, and reduce the cost. So now let's look at the challenge, right? So we have a lot of enterprise customers who are creating a lot of support cases. There are a lot of case activities in that. They also call into our contact center, and the business support team responsible for this spends a lot of time doing point and click, and there are some dashboards that we have built which are static in nature, but they spend a lot of time generating these reports to measure the SLAs, calculate the KPIs. Then we were like, this is a textbook agentic AI platform, so why don't we create a solution for the team by using data agents and blend it with our agentic AI workflow? So that's exactly what we did. If you see here, there are, at a high level, right, 4 layers, right? So we have the Google ADK layer, right, the brain behind this application, right? It is it helps us to orchestrate, analyze the intent of the user prompt that the user entered, and then we have the MCP gateway that is very important to achieve the governance around MCP servers, right? For access control list, I'm going to deep dive into that in a bit, and then it's going to route to the right data agent, which is registered as a cloud run server, and it could be BigQuery, LOIDB, cloud storage, or it could be any other cloud-provided MCP server. And then while this is happening, the agent observability is very important, right? Right from tracing, evaluation, cost, and the ability to basically replay. And also if the application is meeting the right SLAs. So before I jump into the demo, I would just like to show you what's happening behind the scene. As I said, there's an intent engine which basically decomposes the question that the user asks and then generates prompts that go to the data agent, which in turn converts these prompts into multiple SQL queries. And then we're going to use the visualization agent along with the prompt and the data to basically create a dashboard real time. So I think it's a good time to basically show you a live demo, but just a disclaimer that the data shown here does not represent the actual customer data. So can we just transition to my system? So what you see here is the home screen of the Enterprise Service Intelligence dashboard. So you see all the cases that we have created, how many are open, how many are escalated, and how many got resolved, because some of these cases are created by monitoring systems, right? So at a high level, what you see here is what are the current risks and issues that we have across all the cases for all the customers, right? So you could see that there are some no-party resolutions, so we don't know how the issue was resolved. There is some aging hardware fleet that it has detected, right? And there are some ineffective NAT dispatches. So we have a lot of truck rolls that we have to send to the customer side to do the setup with the hardware satellite, and we see that there's some issues. And there are many things like that. There's some issue with some digital signage that is also a service that we provide. So it has basically looked at all your data, and when we have LLMs running in the backend, that is generating this insight at the case level, account level, and at the org level. So it also providing a good AI summary as to what's happening overall with my enterprise customers, right? So there are some dispatch analysis, and it's telling that there are too many alerts created by the proactive monitoring. So there possibly needs some fix, and there are some equipment risks, and then how we are doing regionally, right? So all of those insights are in the home screen, and then I also have per equipment, what is the resolution time, right? With the various hardware products that we have rolled out, right? And then we have different types of data aggregation of what are the calls that we got, billing, service performance, right? And then I could also delve into each of the accounts, right? And then I would get a nice summary of what's happening with this account, right? What are the assets that are here? What is the case volume per week? Which devices are causing these cases? And also, what is the resolution, correct? And then I can also look at all the cases that are causing these issues, and then I also get very detailed insights, right? So this is the dashboard that we have built, wherein we are showing that, okay, what is the operational efficiency, site reliability, and stuff like that. We can also look at individual cases, right? Because each case has a lot of case activities, so we have sort of summarized here, right? And then you can see that this really saves a lot of time for our operational team to just look at the case summary that is generated by AI here, right? And then we also did some grouping by equipment. What are our equipments that are causing most issues so that we can look and fix it those, right? So these are some of our equipments that we have and how they're performing. And then we also have some regional trend as to how many cases are being created and what's causing these cases to be created, right? But that is not why we are here. We are here to show you the agent, right? While all these screens exist, there is always a need for some dynamic data crunching or visualization, right? So here now I have just given a prompt that give me a dashboard of all the B2B cases across the enterprise. So what's happening in the background is the agent, the ADK agent, using the Gemini model, is basically interpreting the question that the user asked, and it's decomposing my question into smaller chunks, and then it's going to the data agent, and these queries are getting generated real time as we speak, right? So it's doing this in parallel, and then once we have these queries, we are running those queries, and then once we have the data along with the prompt, we are passing it to a Gemini 3.1 Flash model to basically generate a visualization real time. So we should see that happening right now in less than 20 seconds. So this is another use case wherein we can use the power of data agents to create very custom agentic AI workflows into your products, right? Okay, so there's an error, but let me just try it one more time. Sorry about that. So it's basically, again, trying to do the same thing, generating the queries real time, and then it's going to run the queries against the database, and then we're going to see a visualization soon. Right, there you go. So if you see here, it has provided a very good summary of AI-provided summary, wherein that there's a massive surge in technical cases, right? And there were almost around 1,052 cases on a particular day, and the service connectivity issues were resolved in 25 hours, right? And it's also giving me a basically trend of how the cases are being created over the week, what is the mean time to resolution for each of this case, and also that basically what these cases are against, right? So we could have issues related to account management, Internet of Things, VoIP, Wi-Fi, digital media, and connectivity, right? And how many cases are pending, open. And then it is also giving you a summary of how much is the average resolution time for each case type. And then it's also giving some key insights and recommendations as to what's happening with these cases, right? Now, we could also have follow-up questions that we could also have questions like, okay, what's happening with a particular customer, right? We could also sort of ask that question. So this really opens up the possibility of basically asking any questions that you might have at a product level or at a customer level or even at a case level, right? So this really is increasing the productivity of our business operations team by more than 60%. So now it has generated the query, right? And then it has filtered the current account name here, as you can see. And then we're going to basically see now that, okay, with this customer, right, that there have been 50 cases over the past 9 days. And you could also see that there are 14 cases that are currently open, and what is the asset health, and what is the basic peak volatility, right? That was on April 4th. And if you can see here, what is causing the issues with this customer, right? So there's a device down. In some cases, the backup is down. And also other technical and admin issues. And then we can see which hardware devices are causing these issues, right? And most of these issues are already detected by our proactive monitoring tool, and it's able to identify that also. And these are some of the cases that we basically see here. Now, the last one is we could also ask that, okay, which products have the most issues, right? And then after this demo, I'll continue with more technical details and continue with the slides. So basically, you can analyze the data across different dimensions here. So it's right now trying to figure out whether this is a follow-up question on the previous question, or is this a net new question for which it has to query the data agent. If the question is a follow-up question, then it doesn't necessarily call the data agent. It's going to use the data that it has in its context. Right? So it has queried a lot of tables that we have, where we have the product information. Yeah, so if you see here that the connectivity issues are caused basically by these two modems that are being highlighted here, right? These are the top products that are causing these cases to be created, right? And then it's also giving that, okay, which product mean time to resolution is slower than some of the other products. And then we also get a trend. And then I can also know that, okay, that what is the concentration of different customers that is leading to these cases, right? And then in a similar fashion, we're going to get key insights and recommendation, right? So can we switch back to the slides. Right? So the way we have built this data agent is basically, as Andrew and Tom said, is we have identified the right tables here, and then we have basically given some sample queries and basically told the agent what its intent is, what it is supposed to do, and then also gave it some business knowledge. And then once we did it, we tested with some sample prompts, and once we got good accuracy, we deployed it as an MCP server using the toolbox that is provided by Google, and then we registered in MCP gateway, right? Now, why do we need MCP gateway, right? Traditionally, without gateway, everybody in the company is creating a lot of MCP servers, or they are directly accessing the data inside these databases using APIs, right? So there is no observability as to what's happening. There is a lot of duplication that's going on. So that's why we need an MCP gateway, because with that, we would know that if there is an MCP server that can be reused for other applications, we can discover that, and then we would have the ability to basically stop any rogue agentic AI applications if they're going into an infinite loop. And that's how we can also make them very secure. So basically, centralized control, fine-grained access control, so that the required client application can only access those MCP servers and tools that it has been given access to. And then we will have a full audit trail of that, correct? And then how did we build this MCP gateway on GCP? Using some of the Google Cloud native services, right? So you have the global load balancer plus Cloud Armor and Model Armor to protect us against any DDoS attacks. Then you have the API gateway for authentication, right? So we would then have an access control list as to what this client can access, which MCP servers and tools, and then using an internal load balancer, it would reroute to the right MCP server, which would connect to the data agent, right? So that is the data plane. We would also need a control plane in the form of an MCP registry, wherein we have a catalog of all the MCP servers within the company, and then we decide using an admin interface who gets to access which MCP server, and there's this whole lifecycle management. We can have time-bound access to all the agentic AI applications. There would be an admin API, right? So this is how we have built this MCP gateway, but there have been some announcements yesterday from Google, wherein I think this now will be provided as a managed service. So do have a look at that, right? Now, we chose Google ADK, and we have a lot of applications wherein we have used Google ADK because of the features that it provides. We can easily create a lot of multi-agent agentic AI applications, as you have seen, 3 in our case, and then it provides native MCP support of the box. And there's also flexible orchestration with respect to the agentic AI patterns, right? Sequential, parallel. We were able to fire multiple SQL queries to the data agent, and then it is also production ready. You could also package it and deploy on-prem, or you could deploy it serverless on a cloud run, or you could also deploy it on the Vertex AI agent engine, right? And in summary, this is a very high-level diagram of what's happening behind the scene. The user comes in, there's a dashboard. You have the intent agent that is using Gemini AI model as its brain, right? Through the MCP gateway, the data agents are being accessed by the parallel data agent that we created. And then we have a visualization agent. Again, we are using Gemini Flash for the same. And then we are using Redis and LRDB. I'll jump into that in a bit. And then for agent observability, we have created our own dashboard. And we have used Google monitoring tools like CloudTrace for the same, right? Now, it's important to note here is that agent memory is a very important concept. We all know that. So here we are using LOIDB as a long-term memory to basically remember the user's preference, patterns, his learning, and all the knowledge, so that we can create a personalized experience. As we have seen with some of the tools like OpenClaw, the personalization is very important, right? And then we are using Redis for storing the session, cache, state, and as a short-term memory, right? So that the agent remembers the context. Now, when it comes to evaluation of these agents, right? If you look at the right, so we had the safety evaluators that we have already built with all our non-agentic AI workflows when we used LLMs, right? If there is any vulnerability, scan, if there's any violence, or if there is any bias or fairness, that we have already had as part of our LLM ops framework. And then we had some quality evaluators, right? What is the quality of the response that the LLM is generating? How do I measure that, right? In terms of its groundedness, coherence, fluency, right? Now, with agent evaluators, we have these new evaluators like intent accuracy, right? How well did the agent understand the intent of the user request? Did it call the right MCP tool? And how well did it execute the task? And overall, what is the response quality, right? So I would say Agent Ops evaluation framework is an extension of the LLM evals framework with some new KPIs. And at the same time, since this is running on cloud, there are some agent-level intelligence, like you want to do the session recording, you also want to do some cost tracking, you should be able to replay what happened with each interaction that the agent did. So we are using Cloud Trace for that. And then also for understanding the latency, since we deployed it as a cloud run, we are using Google native cloud monitoring tools and also to see what are our SLAs, right? So this is how our Agent Ops evaluation dashboard looks. As you can see here, we have all the interactions that have been had with a particular agent, how many tokens it consumed, what is the cost for this application, and then you can see at each level all the evals that I showed you, the intent resolution, task adherence, how well it's doing, and then is there any hate speech, and are there any prompt attacks? Everything, you can track it. You can track it at a session level and also at an individual chat layer, right? And then because ADK provides open telemetry support, you could use the inbuilt pipeline tracing from Google Cloud to basically trace what the agent did, right? So you can see here, it used the intent agent, called the data agent, executed the tools, and then it generated, and how much time it basically took for each of these interactions, right? So if you look at the end-to-end flow, we have the user, we have the intent agent, which would access the data agents using the MCP gateway, and then with the user prompt and the data, we are going to send it to the visualization agent that would generate the dashboard real time, right? So what is the impact of this, right? So we used to spend a lot of time generating these reports, analyzing each case, and at an account level and at an org level. But by building this whole solution with agentic AI and data agents, we are able to generate these dashboards real time. And we are also able to look at some patterns that we were not able to detect earlier, right? And then people can ask any questions that they may have. And I think, thank you all for your time. I think we can take some questions, and I'll request Tom and Andrew to come on stage.
Thank you so much, Amar.
Thank you.